Hello. My name is Joyce Ekanem, and I will be presenting the security framework. Implementing a cybersecurity framework to close organizational security gaps. Sorry about that. Organizational cybersecurity context. Current cybersecurity environment and operational landscape. Current risk management practices and regulatory alignment. Understanding the current cybersecurity environment of an organization is foundational when designing a roadmap to reach a future target state aligned with regulatory and industry standards. Many organizations today operate within complex technological ecosystems that blend legacy infrastructure, cloud platforms, and hybrid systems responsible for delivering critical services. Development processes are often built around the software development lifecycle or the DevSecOps or development security operations methodologies. Embedding security directly into iterative development to reduce vulnerabilities before deployment. Configuration management practices must support consistent system baseline, version tracking, control change management, and timely patching to prevent security drift across environments. Additionally, IAM systems play a central role in controlling user authentication, authorization, and privilege enforcement across endpoints, applications, and back-end systems. Information flows between systems such as enterprise resource planning, customer-facing portals, medical record systems, or supply chain tools must also be protected through layered security controls, encryption, auditing, and segmentation techniques designed to limit exposure. Many organizations continue to face challenges such as limited asset visibility, outdated systems, insufficient logging, gaps in monitoring, and unstandardized configuration practices across distributed teams. These gaps create inconsistencies in how systems are deployed and maintained, which increases the risk of misconfiguration or invisible vulnerabilities. As organizations expand digital services and adopt remote hybrid work environments, emerging threats such as phishing, ransomware, social engineering, and supply chain compromise intensify the need for more mature cybersecurity oversight. Without clear governance, unified configuration, standard, and security-aware development paradigms, organizations struggle to ensure that the systems delivering business or mission-critical services remain resilient, secure, and compliant. Consequently, assessing the current cybersecurity landscape is the first critical step in mapping weaknesses to structured improvement initiatives aligned with recognized framework and regulatory mandates. Current risk management practices and regulatory alignment. Asset discovery and vulnerability assessment, regulatory compliance, influence, organizational constraints and objectives, and NIST cybersecurity framework risk management functions. Risk management is an essential component of strengthening an organization's cybersecurity posture, particularly when aligning with structured frameworks such as HIPAA, PCI DSS, SOX, GLBA, GDPR, or NIST CSF. Effective risk management practices commonly begin with comprehensive asset discovery, where the organization identifies and categorizes hardware, software, data repositories, and network components. Once assets are inventoried, threat modeling and vulnerability assessment help highlight weaknesses that adversaries may exploit, ranging from misconfigurations and unpatched systems to inadequate access controls or flawed development. practices. Organizations must then consider the legal and regulatory requirements governing their industry, such as the HIPAA Security Rule for healthcare, which mandate administrative, physical, and technical safeguards for protected health information, or PCI DSS, which enforces strict controls for payment card data environment. These regulations influence how risk evaluations are conducted and how controls are prioritized. Business and mission objectives also shape risk decisions. For instance, healthcare organizations prioritize patient safety and care continuity, while financial institutions emphasize fraud prevention and transactional integrity. Organizational constraints, including budget limitations, skilled workforce shortages, legacy infrastructure, and operational complexity, further influence risk tolerance and strategy execution. Development threats such as insecure coding practices, supply chain vulnerabilities, or insufficient testing procedures require integration of secure development framework like OWASP, SAM, or adoption of DevSecOps pipelines. Using the NIST Cybersecurity Framework as a guiding methodology, organizations structure their risk management efforts across the functions: identify, protect, detect, respond, and recover. These functions help align security priorities to regulatory expectations while reducing exposure through layered security controls and documented risk treatment plans. Ultimately, risk management serves as the bridge between governance requirement, operational needs, and the organization's target cybersecurity maturity. Framework utilization for cybersecurity maturity, leveraging security best practices and framework. Leveraging security best practices and frameworks. Security frameworks serve as structured references that guide organizations in building, maturing, and maintaining an effective cybersecurity program. Among the most widely adopted frameworks are the NIST Cybersecurity Framework, ISO 27001, and regulatory specific standards such as HIPAA, GLBA, or PCI DSS. These frameworks outline systematic approaches for identifying security requirements, implementing controls, and assessing ongoing program effectiveness. For example, the NIST Cybersecurity Framework offers a highly For example, the NIST Cybersecurity Framework offers a high-level, flexible risk-based model built around 5 core functions: identify, protect, detect, respond, and recover, making it suitable for organizations of all sizes. ISO 27001, by contrast, establishes a formal information security management system with structured governance and continual improvement cycles, emphasizing process maturity and internal control verification. Regulatory frameworks such as HIPAA introduce mandated safeguard and reporting requirements that must guide policy creation and operational design. Best practices including encryption standard, multi-factor authentication, privileged network segmentation, and secure coding principles help organizations enforce practical security measures while minimizing attack surfaces. Combined with industry guidance such as the Center for Internet Security Controls, or OWASP, Secure Development Guidelines, this framework support organizations in aligning with global security expectations, enhancing audit readiness, and maintaining regulatory compliance. By using this framework as references, organizations can baseline their current security maturity, benchmark themselves against standardized criteria, and develop targeted roadmaps tailored to their specific risk exposure and regulatory obligations. When effectively integrated, this framework forms the backbone of a robust cybersecurity program that adapts to emerging threats and evolving business requirements. Organization Organizational decision flow and regulatory needs. Information flow and decision-making structure diagram, critical cybersecurity needs, and regulatory comparison. Understanding the workflow of information and decision across organizational layers is essential in establishing effective governance and cybersecurity oversight. Typically, cybersecurity program direction begins with the board of directors or executive leadership who define the organization risk tolerance, regulatory responsibilities, and investment priorities. These directives flow to the Chief Information Officer or the Chief Information Security Officer who translates strategic expectations into actionable security policies, standards, and programs. Security and IT operation teams then implement, monitor, and enforce control through technical and administrative measures, such as network segmentation, continuous monitoring, access governance, incident response, and configuration management. At the operational level, employees, contractors, and vendors follow established procedures, training requirements, and acceptable use policies that shape daily cybersecurity behavior. Information flow upward through reporting channels such as security dashboard, compliance audits, incident post-mortems, and risk assessments, which help leadership reassess and refine their security posture. This cyclical flow ensures that strategic oversight, operational execution, and workforce participation are aligned to meet regulatory requirements such as HIPAA, SOX, PCI DSS, and GLBA. A diagram representing this flow typically shows a top-down cascade from governance bodies to operational teams, with feedback loops illustrating assessment, reporting, and continuous improvement. Here's a diagram right here, as we all can see. That's the chart right there. Organize critical cybersecurity needs and regulatory comparison. Organizations must implement critical cybersecurity capabilities to ensure compliance with industry regulations while maintaining operational resilience. Compliance framework differ in scope and specificity. For instance, HIPAA mandates administrative, physical, and technical safeguards to protect electronic protected health information. PCI DSS enforces strict technical standards for payment card environment, including encryption, access restriction, and network segmentation. SOX focuses on financial reporting, integrity, requiring strong internal controls and auditability, while GLBA imposes security requirements on financial institutions handling consumer financial data. NIST Cybersecurity Framework and ISO 27001, while not regulatory, provide structured guidance to achieve maturity and enhance governance. Key cybersecurity needs common across these frameworks include encryption of sensitive data, multi-factor authentication, continuous logging and monitoring, incident response readiness, secure configuration baseline, and risk assessment. Prioritization should align with organizational goals, focusing first on high-impact capabilities such as identity management, segmentation, secure development, and disaster recovery resilience by comparing regulatory expectations and mapping them to organizational objectives. Businesses can allocate resources efficiently and build a roadmap that closes gaps between current and desired security postures. Elements of a software assurance maturity model. A software assurance maturity model provides a structured methodology for evaluating and enhancing software security practices across the full development lifecycle. SAM typically consists of 5 major domains: governance, design, implementation, verification, and operation. Governance encompasses leadership oversight, policy creation, compliance alignment, and risk tracking. Design covers architectural security planning, threat modeling, and requirement definition to ensure that security is embedded from the beginning. Implementation focuses on secure coding practices, developer training, and use of automated tools such as static and dynamic code analysis to minimize vulnerabilities. Verification centers on testing, quality assurance, vulnerability assessment, and penetration testing, ensuring that flaws are discovered and remediated before deployment. Operations ensures the secure deployment, maintenance, and monitoring of software through patching workflow, configuration management, incident response integration, and post-deployment validation. SAM helps organizations benchmark their current software security maturity, identify strengths and weaknesses, and plan incrementally toward a more secure and efficient development process. By aligning SAM with regulatory expectations such as HIPAA or PCI DSS, organizations can ensure that development practices reinforce compliance while reducing long-term risk exposure. Conclusion and strategic next step. That's program synthesis and final consideration. Effective implementation of a cybersecurity framework enables organizations to identify and close gaps between their current and future cybersecurity states while maintaining alignment with regulatory expectations such as HIPAA, PCI DSS, SOX, or GDPR. By assessing the current cybersecurity environment, organizations gain visibility into development practices, configuration management, information flow, and system delivering essential services. Risk management practices informed by structured frameworks like NIST Cybersecurity Framework or ISO 27001 guide organization in prioritizing security improvement and allocating limited resources efficiently. Security best practices provide the technical and administrative scaffolding necessary to build a comprehensive cybersecurity program capable of evolving with emerging threats and changing regulatory landscapes. Workflow diagrams and governance models clarify how decisions and information flow within an organization, reinforcing accountability and operational efficiency. Critical cybersecurity needs, including encryption, MFA auditing, incident response, and workforce training, serve as the foundation for building resilience and regulatory readiness. Integrating software assurance maturity models, strengthening development practices, reduces vulnerabilities, and enhances long-term operational stability. Through continuous improvement, strategic investment, and alignment with recognized framework, organizations can advance toward a mature cybersecurity model that safeguards sensitive information, support business objectives, and sustain regulatory compliance. For the references, I use the NIST and the US Department of Health and Human Services. Thank you.